Hello, I'm Professor N.B. Hulle from G.H. Raisoni Institute of Engineering and Technology, and in this video we'll try to understand some complicated sums or few more sums based on this all calculation by using KVL, that is Kirchhoff's voltage law. For this case, I have considered this example, that is calculate the potential difference Vxy and state its polarity for the network shown below. And this is the given network. For this network, we are planning to calculate. This is x point and this is y point. We are calculating Vxy. Now here, this xy has some meaning. This x means higher potential, this y means lower potential. In this case, while calculating Vxy, Vab and so on, we have to travel from the y point towards the x point. Here in this case, we will travel from this y point towards the x point while calculating its potential difference, that is PD. For that case, we have to calculate the current in respective branches available in that particular path. First, we will calculate the current in this particular loop, closed path, and in the second loop, and then we will calculate its potential Vxy. For that case, we have to apply the KVL to this particular loop. First, we have to assume the direction of the current. Here, original direction of the current is something like this, that is anti-clockwise. But deliberately, I am assuming its direction of the current as clockwise. Look, here answer must be negative. This current, I am naming it as I1. Similarly, for this case, the original direction of the current is something like this. I am assuming again it is in the clockwise direction. No difference whether we will assume the direction as a clockwise or anti-clockwise. The solution will be the same in both cases. Now here, if we are assuming the direction of the current as a clockwise, first case we have to mark the polarities. Battery fixed polarities we have, and we will mark the polarity for 3 and 1 ohm depending on its assumed direction of the current. For clockwise direction of the current, it will become positive polarity, negative. Here it will be the plus sign and this will be the minus. Similarly, for the loop number 2, its direction of the current is assumed to be clockwise. That's why it will be the plus, this is minus. For this it is plus and this is minus. This will be the plus and this is minus because the current is flowing in the clockwise direction. Now here in this case, we will start with applying the KVL to the loop number 1. Applying KVL to loop 1. If we are applying the KVL to the loop 1, we will travel from this corner. I will travel in the clockwise direction again. If we are traveling something in the clockwise direction, positive to negative, which is minus, this is minus 4. Then positive to negative, which is minus, its resistance is a 3 and its current will be the I1. That's why its potential is 3I1. Then here we are traveling in the downward direction for the resistance 1 ohm. That is positive to negative, which is minus. Its current is I1 and its resistance will be the 1 ohm. That's why its potential will be minus I1. And then we are coming back, no element which is equal to 0. We see here in this case, its equation will be, that is minus 4 and minus 4 I1 which is equal to 0. That's why here that is minus 4 I1 which is equal to plus 4, and then I1 is equal to, it is minus 4 upon 4 which is equal to minus 1 ampere. Now look, what this minus sign indicates, the assumed direction is not wrong, but it is reverse as that of the original direction. That's why the sign is coming to be negative. If I assume this direction anti-clockwise, then this answer will be the plus 1. But no issues, according to the polarities we have to calculate its values. Similarly, here I am applying KVL to the loop number 2. If we are applying the KVL to the loop number 2, we will travel from this particular point again in the clockwise direction. Here we are traveling from positive to negative, which is minus 2 into its current. Its current is I2, then positive to negative, which is minus, its voltage is 10, then positive to negative, which is minus, its resistance is 6, its current is I2, then positive to negative, which is minus again, 2 into its current is I2, which is equal to 0. Now here in this case, if we are simplifying it, then it is 6 plus 2, that is 8 plus 2, that is 10. Yes, it is minus 10 I2 which is equal to 10, And finally, if we are calculating the value of the current I2, which is minus 10 upon 10, which is nothing but again minus 1 ampere. Now look at this minus sign again. In this case, original direction of the current is anti-clockwise. I have taken it as clockwise. That's why its current is coming to be minus 1 ampere. No issues? Now here we know the current in all branches, all paths. Now here we'll try to find out here the potential Vxy. Now this Vxy, which is equal to, we are traveling from the y point towards the x, because x is the lower potential point and y is the lower potential point and x is higher potential point. We are traveling from the y towards x. Is here in this direction, positive to negative, which is minus, resistance is 2, its current is I2 and I2 is minus 1 ampere. Then here we are coming down, positive to negative, which is minus, its voltage is 5. Then we are coming upward, negative to positive, which is a plus, its resistance is 1 and its current is minus 1 ampere, which is equal to here, that is minus into minus, that is plus 2 volt, then minus 5 volt, then again this will be the minus, here in this particular case, look at, for this 1 ohm, it will be minus 1 volt. Minus 1 volt means here in this particular case, if we are calculating its value, it will be 2 minus 6. And its value is coming to be, which is equal to, that is minus 4 volt. Minus 4 volt is the value of the current in this particular case. Now here, if we have calculated this value, now here we can state its polarity. Its polarity is the negative and its value of this particular potential is the 4 volt. This is one of the example. In this particular case, these are some calculation related to this. Now here, I will go through another similar example. But here, it has a current source. Only difference is that, and this common branch has the resistance of the 10 ohm that we will see. Now here generally at the beginning or at the initial stages, for this particular loop we will assume the direction of the current same as the direction of the current source. Then when we will understand few concepts, then we can assume its direction in opposite direction also. Now here I am naming this current as I1, and here in this particular case we can assume this current as a clockwise or anti-clockwise, but here in this particular case I will assume this particular current again as a clockwise direction, which is, I will name it as I2. Mark the polarities here. The polarities for this particular case is, it will be the plus, minus, this is plus and this is minus, this will be the plus and minus. For this particular clockwise, it will be the plus, this is minus, this will be the plus, minus, this is plus again, minus, and finally these are the polarities for 1 ohm resistance in this particular case. Now here if we are applying the KVL for the loop number 1, why we will apply the KVL? We will apply the KVL to calculate the values of the currents. Here, no need to apply the KVL for loop number 1 because I1 is already known, which is given as a current source and its value is 2 amperes. That's why I will not apply the KVL to the loop number 1. But here, if we are applying the KVL to the loop number 2 and if we are traveling from this particular corner and we are traveling in the upward direction, here positive to negative, which is minus, its resistance is 8 and its current is I2. Then positive to negative, which is minus, its resistance is 3 and current is I2. Then positive to negative, which is minus, its resistance is 1 and its current is I2. Then positive to negative for the battery we are traveling, that's why it will be minus 30. And finally for if we are coming back, then positive to negative, which is minus I2, which is equal to 0. This is application of the KVL or Kirchhoff's voltage law for this particular case. If we are simplifying, it will be minus 8I2 minus 3I2 minus I2, then again minus I2, which is equal to plus 30. Then it is 8 plus 3, 11, this is 12 and this is 13. This minus 13I2, minus 13I2, which is equal to 30. And if we are calculating the value of the current I2, which is equal to minus 30 divided by 13. And if I am using the calculator for this particular case, and if we are calculating its value, it is coming to be minus 2.3 amperes. Minus 2.3 amperes. This is the value of the current I2. Now here, we don't know the current in this branch. What will be the current in this particular branch? This is common. Now here, for that case, we need to understand the basic rule of the battery. What is the basic rule of the battery? Whatever the current leaving the positive terminal of the battery, same amount of the current must enter into the negative terminal of the battery. Here, if some current is traveling in this direction, then there is no back path. There is no back path for the current. That's why whenever such circuit is there, then always current in this branch, that is current in the 10 ohm resistance, is always 0. But still, the 6 volt potential exists. 6 volt potential exists even though the current in this particular branch is 0. Now here, if we are calculating its value of the current in this particular case, potential VAB, now this we have to travel from the B point towards A point. This is B point and we are traveling towards the A point. Now we can use any path. In the previous example, I have not discussed that. If we are using this path or maybe this path, use any path. Its value of the voltage is always same. Potential difference between the 2 points is always same. But here in this case, we cannot use this path because we don't know the two things. Directly, we don't know the current flowing through the voltage source and voltage across the current source. We have to calculate these values indirectly. That's why we don't know the voltage across this current source. That's why we cannot use this path. We can use maybe this path or we can use this path. Always we have to select the shortest path. That will reduce the calculation and that's it. Nothing else. Now if I am traveling in this direction, positive to negative, which is minus, its resistance is 1 and its current is I2, which is minus 2.3, which is minus 2.3. Then positive to negative, which is minus, its resistance is 8 and again its current is minus 2.3. Minus 2.3. Its current is minus 2.3. Then we are traveling in this direction. Voltage across this resistance will be 0. Plus or minus 0? No meaning. Then negative to positive, plus its voltage will be the 6. Then if we are going upward, in that case positive to negative, which is minus, I will take here. This is minus. Resistance is 2 and its current is 2 amperes. Then positive to negative, which is minus 5 and its current is again 2 amperes. Now if we are simplifying this, which is equal to this minus of minus, that is plus, that is 2.3, then minus into minus, that is plus, that is 8 into 2.3. If I am doing that calculation, here it is 8 into 2.3, which is equal to, that is 8 into 2.3, that is 18.4. This is plus 18.4 plus 0 plus 6, then minus 2 into 2, that is 4, then minus 5 to the 10. And if I am calculating its value, it will be, now here that is 2.3 plus, it is 18.4 plus 6 minus 4 and minus 10. Here in this case its value is 12.7 is the potential VAB for this particular case. That's it. These are the some simple tricks and techniques can be used for calculation of the parameters depending on the requirement by using the KVL and KCL. In the next video I will discuss about the mesh analysis or loop current method to calculate the values of the currents using the mesh analysis. Thank you.